Did you guys do anything crazy for April Fool's Day? You what, Shua? Oh gosh. Ooh, that's wicked. You did that? So did they assume that there was like a breaker blown or something? That's a pretty good prank. Did I assume you went back and screwed them all back in? Oh yeah, good. Because that would turn from a prank into just being mean if you made them go to it, you know. Nice, well played. Way to take advantage of April 1st. It's good work. So you guys who are pretty good with your basic skills will do better today. If you struggle with times tables, there are resources. So we're going to make a kind of a cheat sheet here as we go today. This is something that will stay with you now forever in math class. Like it's not going to stay with you when you're 32 years old, you know, walking around Walmart or whatever. Like, but when we talk about important stuff in the context of mathematics, this just becomes like if you look back on the day that your fourth grade teacher taught you how to simplify or reduce a fraction, you know how that just kind of never went away, right? Like it's just there, it's always there. This is like that, except this is like the high school version of that. So um, let's run through and make sure you know your basics first off. Like you guys all know what's the square root of one? One. What's the next number that you can square root? Say it again. No, you can't square root of two. You listen, when I say can't, I gotta stop saying that. You can take the square root of two, but it's not going to end well. It's like 1.4 or something. Like we don't want that. Like I want to know what's the next number that's perfectly square rootable. Four is, but two is not, and three is not. So if we skip over one, we could say that the square root of four is equal to two, right? What's the next number after that? Six is not square rootable. Nine, however, is square rootable, and so on and so forth, right? What happens is these numbers start to get further and further apart, right? Like when you went from one to four, you only had to make a little baby jump. Four to nine was a little bit of a bigger jump. What comes after nine? Right. Good. So I'm going to cease with writing the notes like this. I just want to make sure you guys understand that some numbers can be square rooted and come out even, whereas the vast majority of numbers cannot. So what we're going to study today, first off, is the list of numbers that can be square rooted perfectly. And having taught this lesson or some version of it for a long time, I've decided I always write these in red. So I'm going to refer to this as the red list. And the red list is critical. So I doubt you have colors there at your disposal, and that's okay. But what we're going to do is we're going to start making a list of numbers. And this list is special because the numbers in this list are the numbers that if you take the square roots of them, good things happen. So we're going to start obviously with the number one. He's the first number on the red list. Quite frankly, full disclosure, pretty worthless. It's like the square root of one, as you'll see in today's lesson, does us no good. But let's acknowledge at least that he's there. And next on the red list is four, right? And after four, who's the next number that can be square rooted after four? Nine. After nine, good. And this is where we stopped. So this is all going to be kind of a new adventure. We'll take this pretty far. All right, you'll run out of room. I've taught this lesson 100 times, and I don't have a board wide enough to hold how far we're going to go. So eventually we're going to get to a point where my list has to start curling down the side of the television. So yours might as well. So just be prepared for that. I don't know. What's after 16? 25. These are significant numbers. You want to come to know them very well. Who's after 25? 36 is, right? Look at how far apart the numbers are getting now, right? We have to jump now quite a ways. And there's actually a pattern to the jumps if you're interested. Like, can you see the pattern, how it's +3, +5, +7, +9, +11? So it's not really very useful, but it's kind of cool to look at. What's after 36? 49. And you already have a paper resource that would guide you through what these are. Like you have a piece of paper that I gave you probably last week that has these numbers all on there, right? Try to do them from the top of your head. Test yourself. What's after 49? Yep. After 64 is 81. And then we get to at a significant point in the list after 81 is a perfect 100. And that number will prove to be quite useful for a lot of the problems we have to do today. After 100, 121. Listen, to be square rootable, you have to have been the result of squaring something else, right? So as we go through this, if someone is giving me answers and not looking at that piece of paper, you might wonder like, God, how did they know that? Well, think about what these are. Like 1 was 1 squared, right? And 4 was 2 squared. So if you know your basic times tables, then you can go pretty deep into this list, even if you didn't have that piece of paper in front of you. And this is the one where you probably stopped learning your times tables. This is the last one that they teach in 4th and 5th grade. What's the next one after 121? 144. Right. And that's usually where an elementary teacher is like, okay, I need you to know your grid 12 by 12. Right. That's always the goal. And then no one teaches past 12. Like it just doesn't usually happen. So what's after 144? 169. Very good. Yeah, and it's okay if you just take a guess at these, and if they're wrong, like it's all good here, you know that. So we're getting into the tougher spot now. So that was 13 squared to make 169. What's after 169? Yeah, 14 squared is 196. Very good. After 196, 225. That's 15 squared is 225. After 225, 256. And as you can see, as advertised, I am officially out of space. And so I'm going to start creeping down the right side of my television. I probably could make it fit, but it just, the nature of this is just, it's always right around here that I run out of real estate. So that was 16 squared. That leads us to another one that's like most people just don't know, but let's give it a shot. What's 17 squared? 289. And that takes us up to 18 squared. 324. And by the way, if you ever want to know what these are and you don't have something there to help you, just use common sense to at least guide your guess. So like take this one, for example, the 289. Like let's say I don't know what 17 times 17 is, but if you think about 17 times 17, you see how the numbers end in sevens, right? And what's 7 times 7? 49. So if the numbers end in sevens, then you know that your guess has to end in a 9. So that's sometimes a good way if you're not sure, like if you're trying to do it in your head, you can think about what does it have to end with? It won't tell you what it is, but it'll certainly give you a good direction, I think. So like if for 18 squared, if you said something like 361, then you'd go, well, that's not possible because 8 and 8 make 64. It has to end in a 4, right? And that takes us to the next to last one, which is 19 squared, which is, it has to end in a 1, 361. And then that takes us, of course, to the easy one that we don't need a piece of paper to tell us, and that's 20 squared, which is 400. That is where my red list will end. That's where I tend to focus most of my test questions, and those are the ones that you'll generally see the most are, can I understand that those 20 numbers, right, are on the red list? In other words, they are all significant in that if I square root them, I get a good answer. What we're going to avoid are square roots that have decimals. Like if I give you the square root of 6, you don't want to say 2 point something. Like even though that is what it is, that's not what we're doing today. So if you ever get a square root and put a decimal, that's called approximating a square root. That means like I'm getting kind of close, but that's not what the mission is. The mission for today is this word, simplifying. That is what we're learning to do today, is to simplify. Now, today's lesson is not just about taking square roots. Like I'm rarely going to ask you just what's the square root of 324. Like if you happen to see that on your assignment today, then you go, oh, well, jackpot, I happen to just know that that one's 18, right? Today's lesson is about the numbers that are not on the red list. And how do I work with them? And I say the skill that we acquire today becomes as important and every day as reducing a fraction or 2 plus 2 or 9 times 6, like just the basics that we expect you to know. Okay, so this will carry over for this year, Algebra 2, advanced if you take it. I mean, like there's no math that you ever get to where you go, oh, God, I don't have to reduce these anymore. So let's get to it. Say I asked you for the square root of 8. First thing you want to do is check your red list, right? Because if it's on the red list, then you don't want to do what we're learning today. You just want to take it. Like if the square root of 8 was on the red list, then I would just give the answer. But 8 is obviously not on the red list, right? So our hope is that we can simplify. And again, the expectation is just like reducing a fraction. Like if you put 3 over 6, like let's say we were solving an equation and you put x equals 3 over 6. It's not mathematically technically wrong. It's just that all math teachers would take some amount of care to say, you need to fix that because what should it be? A half, right? So reducing or simplifying roots is like that. You're not wrong if you say the square root of 8, but you'll still get dinged because it's not like acceptable use of the language. The language of math has rules just like English. Okay, so if I gave you the square root of 8, what we're going to do, and I'll show you a couple different ways, and here in about 10 minutes, I'll kind of ask you guys which way you prefer. One method to do this is by making a little factor tree like this. And I'll let you pick whichever one you like better. I don't care. This is the part where I fail. I don't know. I don't think it's necessarily that I fail. I think that I don't try hard enough. So my students think that what I'm about to say is not important. At the end of each of those branches, I need you to do this. I need you to put a blank square root sign and a times sign and another blank square root sign. At any grade level, there's always a point where a kid says, I'm not going to do that. And then they say really funny, bad things. So at the end of each branch, put a blank square root and just set the workspace. Now, can you think of two numbers that multiply to make 8? But the rule is that one of the two numbers has to be on the red list. What would they be? 4 times 2? Mm-hmm. Now, 4 is on the red list, right? So I'm always going to put the red list number first. Whether it's bigger or smaller, that is irrelevant. Put the red list number first and put the useless number second. We all agree that 4 times 2 is 8, right? So there's a property of radicals roots that says if I multiply a root by a root, I just get another root that is the number multiplied together. The numbers multiplied goes inside. So 8 is 4, 2, right? What is the square root of 4? Therefore, I can say that the square root of 8, when simplified, equals 2. And that comes from that root right there. The way we read this, get used to this. This is going to become a common part. We say this out loud. 3 words, 2 root 2. That's how you read that. You don't have to say 2 times the square root of 2. You just say 2 root 2. Let's practice again. I'm going to show you, by the way, another way to do that. This is the tree method. The other way to do it is the sideways method. And that's where you just make a square root sign, but you make it a little bit bigger. So rather than making a tree with 2 separate roots, you can put your red list trash number inside the root like this. And again, the numbers that multiply to make 8 are 4 and 2. And then, of course, you can see now that the 4, the guy that I wrote in red, he's going to break out of jail. He's my jailbreak. And when 4 breaks out of jail, what does he become? So that's another way to get 2 root 2. You'll decide in the coming 15, 20 minutes which method better floats your boat. Some people really love the tree. Some people really love the single root with the multipliers inside. And I could not care less which one you pick as long as you are acing it. Okay, here we go again. Let's try the square root of 45. Before I even think about the math. This is where I fail. Like, I don't know what I say that isn't clear. Before I even do the math, I draw my blank square root signs. Now, there are multiple ways to make 45. Let's say I picked 3 and 15. Why would you tell me that I'm a bad person for that? Hey, by the way, 3 times 15 is 45, just FYI. But why is that a bad decision? None of them are on the red list. So that's trash. And you're going to find this a lot of options for a lot of numbers have like tons of ways you can do it. And there is always a best way to do it. And 3 and 15 is not that way. So don't pick numbers that are not on the red list. It's a waste of lead. It's a waste of your time. What numbers are we thinking of? 9 and 5 for sure. And again, bigger, smaller does not matter. The red list number should always go in the first one. The trash number should always go in the second one. And what is the square root of 9? So how would we say this answer? Perfect. 3 root 5. It's just like reducing a fraction. Good. Let's go again. Square root of 27. I use the tree a lot, by the way, so you'll notice that that's more commonly how I do it. So what are we thinking for 27? 9 and 3, right? So I'm going to put the red list number first. My 9 goes first because he's the good guy. And then the trash leftover number is the 3. So what would I say is my answer? 3 root 3. Still good? Okay, how about this one? How about the square root of 500? It's big, but the thing about it is there's a really big helper number, and I'm going to scroll back up a little bit and I'm going to circle it for you. 100 is your best friend in situations like this. I kind of alluded to this a while ago that he was going to be really useful. And 100 is sweet because you can make huge progress and with one simple number. We all know that 100 goes into anything that ends in double zeros. Of course, you learned that in like 4th grade, right? So before I begin the math, I'm going to draw my branches and draw my 2 blank square root signs. Which one am I going to put in the first one? 100, definitely. Gets the red, and then 5 is the trash. What's my answer? Good. 10 root 5. Okay. Today's lesson is going to now consist of me running through a bunch of practice, and then I'm very specifically going to give you a list of death numbers, the numbers that will cause you grief if you're not careful. So we're going to all write them down. This is not a death number. This one's just annoying, but the death numbers are 32, 48, 80, 96. There's some others. They're terrible numbers because they make us want to say things that are not right. Anyone figure out 98? That's not a common times table thing for people. Gage?
98 times 1.
Never ever use a number. If you think about it, this is I gotta be some sort of a definition of insanity, right? Imagine if I did 98 and 1, and then I was like, ooh, I think I'll make another tree, and I'll make 98 and 1. And then I'll go, ooh, I'll make another tree. You see that we're headed down a really deep, steep, dark pathway here, right? So please don't ever, 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 ever use a number times 1. It is a waste of time. There is a good way to make 9. This is where we start to find ourselves now scouring the red list. You're going to want to make sure you have a good, neat version of that someplace, and you're going to start going through and checklisting and saying, does that work? Nope. Does that work? Nope. Does that work? And the more practice you get, you start to memorize. Like by the end of the day today, you'll see 98 and know exactly what it is. Did you figure out the actual answer? 16 times 4 is 84. Mila's got it. It is. So let's go ahead and make our branches. Draw your 2 square root signs. And in we go. 49 is on the red list, and it just so happens that if you take 49 and multiply it by 2, you get 98. And what is the square root of 49? So we would read this as 7 root 2. Okay. How about this one? By the way, there are a lot of ways to multiply to make 84, and I'm going to run through them with you over here off to the side. I'm going to write them in purple. The first one, and I'm never ever going to mention 1 times 84. I'm going to say that there is 2 times 42. There is 3 times 28. There is 4 times 21. And there is what Gage said last time, and that is 6 times 14. And I believe that's all the ways to make 84. What do we think of 2 and 42? No good. Why? No one on the red list. Trash. Cross it out. Boom. 3 and 28. That's got to be good, huh? Nope, not on the red list. 4 and 21. 4 is a winner. But I don't want to stop there because there could be a better one. What about 6 and 14? You like 6? Nope. You like 14? No, it's trash. So 4 and 21 is our guy. So you're going to find numbers that have a lot of meat on that bone. There's a lot of factors, and you've got to sift through and find the combination that suits our needs. So when I take my root of 84, branch, branch, root, root, just like that. And I'm going to put the red list number first, bigger, smaller, doesn't matter. And then the trash number second. And so what's my answer? Good. Now, if you follow directions well today, what I'm about to say will never matter to you. But, you know, I work with humans all day, and humans sometimes think that they just like to go rogue. So here it goes. There's going to be a chance that the trash number could go further. And so I don't want you to write this down, but just kind of pay attention to this. 21 is not, by what we understand about numbers, 21 is not dead. 21 is not prime, right? So if I made a tree off of 21, what are the only numbers that could go into 21? 7 and 3. What do you think about 3 and 7? Trash and trash. Therefore, we stop at this point because 21 is what we call a dead root. Okay, once you hit a root that can no longer be simplified using red list numbers, it's a dead root. The answer is 2 root 21. Is this making sense so far? Mm-hmm. Now I'm going to show you a list of numbers that your brain will try to get you to miss because your brain is like that. So here it goes. The first one, and you wouldn't even guess it from looking at it. It looks so innocent and fluffy. It's one of the most commonly missed roots, is 32. So these numbers, the ones you're about to write down, eventually you're going to want to separate them. Like before quiz day, whenever that is, you're going to want to separate these into their own little box and call them death numbers. Because there's a lot of them, and they make us want to say bad things. What's the first 4th grade times table problem that comes to mind when you think of 32? 4 and 8. And I heard the number that I wanted, but the human brain, if you were trained well by your elementary teacher, you think 4 times 8. Now I'm going to show you why that's a bad idea. So let's go ahead and make our branch, branch, root, root. And if I do 4 and 8, 4 would go first, right? And 8 would go second. The reason this is a death number, and I call it this because after so many years of teaching, if I had $1 for every time someone submitted this as the answer to root 32, I could probably pay off my house. What's wrong with this answer? Yeah, 8's not dead. 8's not a dead root. And I never want these problems to take more than one step, but I guess I'm up against it now because I made a bad choice. So branch, branch, root, root. I got to take, it's like the, you know how factor trees go, they grow, but then sometimes they grow and they keep growing off of their own branches. What does 8 break down into? 4 and 2. Which gives me down here 2 root 2. But now the trouble is you've got to go back and gather up all the pieces. So you have to go back and identify who are my jailbreaks. Well, 2 was a jailbreak, right? And this 2 was a jailbreak. And what is 2 times 2? So my answer is 4 root 2. So the question is, how could I have gotten there quicker? No one ever wants these to take more than, that's confusing. Look, it's a mess. So yes, the answer is And this is the part of the lesson where I hope I'm not too far past my time where you stopped listening, where scientists say people don't listen beyond this point. I hope I haven't blown it. Do not stop and pick a red list number just because it works. Only pick a red list number when it's the biggest and best one that works. Your job is to look at 4 and 8 and say, I don't like 4 and 8 because even though 4 is pretty rad, that number that would be trash, I don't want to have to work him again. So I'm always going to dig as deep into the red list as I can. And I did hear it right away from back there somewhere that when I branch, root 32, I want to use 16 times 2. That's hard for us because, again, if someone did their job long before me and taught you your times tables, 32, you're like it's a conditioned response. 32, you think 4 times 8, 4 times 8, 4 times 8. That's what someone got paid to get in your head. Don't use it. 16 and 2 takes us straight to 4 root 2. Done. Got it? 32 is a death number because of the first way I showed you how I did 4 times 8. The death numbers that I'm going to show you for the next 5 minutes all like to get people to say the wrong red list number. Don't fall for it. Got it? Here comes the next death number. And again, you look at it and think, it's not hard. 48. Stinking 48. There are 2 that someone got paid, whether it was your mom and dad from the front seat while you were driving to Walmart or go see grandma or your times tables or some computer program. Someone made darn good and sure that you think of 6 times 8 or 4 times 12. Those are on that 12 by 12 grid that should be etched in your mind, right there up in the gray matter of your brain, right? Don't pick either of them. 4 and 12, you think, well, 4 is pretty rad, like 4's on the red list. I can go better. Does anyone know what the best way to make 48 is? It is. So that's why this makes the cut as a death number, is because, again, our brain's going to make us want to say 4 times 12 because it feels so good to get to 4. Don't fall for it. So branch, root, 16 yet again rears its ugly head. 16 times 3 makes 48. And this is why we take notes, so we can get these death numbers in our notes. What's the square root of 16? 4 root 3. Next death number, you'll start to see a little bit of a pattern here with the death numbers, is 80. Again, 8 times 10 should have instantly flooded into your brain, and you should have instantly kicked it out because 8 and 10 are trash. 40. Say again? 40 and 2? Yep, both trash, right? 40's not on the red list, 2's not on the red list. How about 4 times 20? That's delicious, right? You guys like 4 times 20? Yeah, you should hate it. Good. Thanks for not falling for the inflection of my voice. 4 and 20 is like, yay, I found a 4. Because then the 20 requires more steps. Never put yourself in a position to need more steps. What's the quickest route to 80? 10 and 8 will do us no good. 10 and 8 are both trash. Never pick trash numbers. There's a lot of ways to make 80. 2 and 40, 4 and 20, 5 times 16, 8 times 10. What? 16 and something. Yes. Turns out that 16 times 5 makes 80. And we love the number 16, even though it keeps trying to get us. We're not going to fall for it, right? 16 times 5 makes 80. What's the square root of 16? 4. I'm not going to ask you this question because you know the answer, but you have seen, obviously, that the number that keeps causing us grief is 16. Watch out. Put these in your notes and separate them from the others. 32, don't fall for it. 48, don't fall for it. 80, don't fall for it. And there's one more, actually a couple more, and you might have guessed where this was headed, but it's this one. And this is where our notes just save the day. Having notes for these just saves the day. Anyone knows 96? I'll go ahead and get my branch, root ready while you guys are figuring it out. 8 times 12. 16 and 6. 16 gets used a lot, and I stress it at the front end of this lesson a lot because I don't want you guys to fall prey to 16. We never learn our 16s, and it's not our fault. No one teaches us 16 tables. We stop at 12s. There's 16 again, trying to mess with our head. What's the square root of 16? So we get 4 root 6. And again, 6 is not prime, but if you break it down, his factors are trash and trash, right? 2 and 3, useless. So we stop. 6 is a dead root. How about this one? And just add these in. If you see them, jackpot. If you don't, at least you got them. And at this point, I see that Landon just threw that out as a I'm following Mr. Ahern's pattern guess, but you're exactly right. There's 16 again doing his evil bidding. Like, does anyone normal know that 16 times 7 is 112? No. Just weirdos like me who do this all day, right? But it turns out 16 times 7, it makes 112. And square root of 16 is 4. Got it? There will be more death numbers. And as you encounter them, I want you to save a space in your notes, put a big empty space, fill it up, but then leave room to put more. Because every time you get one that you go, oof, that one's nasty. Took me all 3 tries on Delta Math to get that one right. Every time you get one, add it in. Add it in. You're building like your own cheat sheet here. The sheet I gave you is good, but it's not going to help you with tricky numbers. All right, let's get back to it. So that's all the depth numbers for now. Let's practice some more. Branch, branch, root, root. There we go. Ready to go. I will again not mention 1 times the number. There are 2 other factor pairs that make 75. One of them is 5 times 15. You like it? Trash. What else? Yeah, if I told you I had 75 cents in my pocket, you would probably assume that it's built by coins worth 25 cents each and that I have 3 of them, right? 25 threes, 3 25s. What does that become? Good. You okay? How about this one? Pro tip, jackpot. Sometimes you'll find yourself scanning the red list from left to right, but sometimes you might find it's more efficient just for, giggles to say, maybe if I just tried dividing this by a useless pile of garbage like two's trash. But if I divide a number by 2, sometimes the other number won't be trash. It'll be a really big, useful number. And like Brendel just figured out, if I divide this by 2, what's half of 128? Jackpot. And 64 is magnificent. What's the square root of 64? 8 root 2. Got it? How about this one? Go ahead and try the trick of dividing it by 2, and you'll quickly realize that that fails, because 2 and 54 is trash. But 3 is also trash. I hope you're in the lesson enough that you know what I mean when I say trash. 3's trash. But try, and you can use your calculator a little bit, try dividing 108 by 3. Again, 3's garbage. But it's not the garbage that I'm interested in. It's what's the other number that's not garbage. 108 divided by 3. Say it again. Beautiful. Wonderful. And what's the square root of 36? 6 root 3. Where this becomes a slippery slope is this, and I'm telling you as a guy who's seen this, I think I can say this now thousands of times, is that a kid who scans the red list from left to right is immediately, and I mean almost immediately, going to find this. And they're going to get so excited. because they tried, 4 and it didn't work, or it did work, and then they tried 9 and they go, oh, that's got to be the winner, right? 9 and 12 make 108. What's wrong with 12? Yeah, it's not dead. You always want the one that I keep writing in white to be a dead root, and 12 is not dead. So you picking up what I'm putting down here? So your job is to, by the way, there is a right answer. If anyone ever tries to convince you that there's not, they are lying to you. There is a best way. Just like if Mrs. Happerschlammer puts 12/24 and says, all right, class, I need you to reduce this. And little Johnny puts 6/12. It's okay, good job, Johnny, but it's wrong, right? And then if little Sally puts, oh, I got it, Mrs. Happenschlammer. Sally's not there either, right? You see what I'm saying? Like there are ways to get there, but there is a destination that you need to get to. So I upped the tries on Delta Math to 3. So what it means this time is if you miss it once, it'll say, sorry, your answer is not correct. Please try again or whatever. If you missed it a second time, you'll get one more shot at these. Okay, so you shouldn't have to go backwards much. But your assignment is on Delta Math, and it's just a bunch of these. That's all you're doing is simplifying roots. Okay. And yeah, having some paper out is a pretty good idea. Some of the smaller ones you'll start to do in your head, but bigger numbers, you're going to want scratch paper. Yes. Yes. I'm going to pause the recording, but when the first kind of, oh my, that's a good question comes up, then I'll throw it in the recording here. What if you're working through, and this will happen, by the way, what if you're working through your Delta Math and you get the square root of, I don't know, like 144? I hope you're listening. What would you do for 144? It is just 12. And I'm not gonna lie, I do get slightly entertained when kids take these and go branch, root, because I'm like, what are you doing? Like, look at the red list first, square root of 144, you just put 12 and it's done. Like, so if you happen to see one that's just on the red list, take it, run. Don't make a tree. It's just easy, right? Okay, watch out for those because they will pop up. Yeah. Did you already get one? Sweet. What is the number? Okay. So remember what I said is sometimes if you take a number, like we would agree if we did 147 divided by 2, you're smart enough to know that that's not even worth trying because it's odd, right? But remember, 2 is trash anyways, but sometimes dividing by trash can lead to good. So let's go with another trash and let's try dividing it by 3. And again, 3 is garbage, right? But I'm not interested in the 3. I'm interested in what might pop out. What's 147 divided by 3? And that is significant, right? So that means that when I treat it down and I got trash on the right, I'm good with that because the number that I get on the left is far from trash. It's 49. You see how that works? And if that doesn't work, then sometimes it's a good idea to start just grinding through the red list and try dividing it by things like 9 and, whatever you want to. But you kind of have to decide, do I want to come at it attacking it actively by the red list or dividing it by little baby trash numbers that might produce a big red list number? That makes sense? Yeah, so 7√3, right? Okay, good. By the way, I will give you more time tomorrow to work on this, in addition to a different assignment. Like, I know I do that sometimes, but you'll have time in class still for this, but then I'm going to add on to it another version of it as well. So just be advised.